In this video, we are going to look at the concept of buffer solution and Henderson-Heisenberg equation, how we can use the Henderson-Heisenberg equation to calculate the pH of an acid buffer, and also use the equation to calculate the pOH of a base buffer. Alright, so let's begin with buffer solution. Okay, so basically a buffer solution is a solution that can resist a change in pH when small amounts of a strong acid or base is added to it. Alright, so we have acid buffer. We also have base buffer. Alright, so acid buffer is prepared by mixing a weak acid and its salt, whereas a base buffer is prepared by mixing a weak base and its salt. Okay, so let's look at the Henderson-Heisenberg equation for calculating pH of an acid buffer. Okay, for pH of an acid buffer using Henderson-Heisenberg equation, so we have it to be pH equals pK plus log the conjugate base over the acid. Alright, so this is the conjugate base, whereas the pOH of a base buffer using Henderson-Heisenberg equation is calculated using pOH equals pKb plus log the conjugate acid, which is a salt here, over the base. Right, so this is salt, this is conjugate acid. Okay, so the pKa and pKb are usually given in the question you are asked to solve for each acid buffer or base buffer. So for where the pKa is the negative log of Ka, whereas the pKb is the negative log of Kb. Alright, so having known this, let's wipe them now and solve a typical problem on this so that we can understand how to apply this formula very well. Okay, so let's look at this question. It says a buffer solution contains 0.1 mole ethanoic acid and 0.1 mole sodium acetate. If 0.02 mole of sodium hydroxide is added, so we are given the Ka value to be this. What is the pH of the solution before addition of sodium hydroxide? B, after addition of sodium hydroxide. So let's solve for A, before addition of sodium hydroxide. So we're going to have the pH before addition of sodium hydroxide will be pKa plus log the conjugate base, which is the salt, over the acid. Alright, so where our pKa is negative log of Ka, we are giving the Ka to be 1.8 times 10 to the power minus 5. So going to be negative log of 1.8 times 10 to the power minus 5. So let me point it to my calculator here. Okay, so we have it to be 4.74 if you are leaving it into decimal places. Alright, so the pH will be input the value for the pKa, which is 4.74 plus log, then the conjugate base, which is the salt, the concentration there, we have it to be 0.1 over the concentration of the acid is also 0.1. So let's simplify log 0.1 divide 0.1. Let me punch it. Okay, so I have it to be 0. Therefore, the pH before addition of sodium hydroxide will be 4.74 plus 0, which is the same thing as 4.74. Alright, so let's wipe below and solve for the pH after addition of sodium hydroxide. Okay, so the pH after addition of sodium hydroxide will be that of the conjugate base, that's the salt. The concentration will increase by 0.02, whereas the concentration of the acid will decrease by 0.02. Alright, so we're going to have pH equals pKa plus log. So we have the salt, concentration of the salt plus 0.02 over the concentration of the acid minus 0.02. Alright, so when you simplify, you're going to have, let's put this in brackets. Okay, so pH will be, the pKa, we got it to be 4.74, alright, plus log. We have the salt, the concentration of the salt is 0.1, alright, plus 0.02 over that of the acid is 0.1 minus 0.02. Okay, so when you simplify everything here, then punch it to my calculator. So when you punch everything, I'm going to have 4.916. If you want to leave it in 2 decimal places, it will be 4.92. Alright, so this will be the pH after the addition of sodium hydroxide. Alright, so let's wipe it and solve one more problem before we call it a class. Okay, so let's look at this problem. It says the paper solution was prepared by addition of 0.005 mole hydrochloric acid to a solution of 0.1 mole sodium acetate and 0.03 mole acetic acid. Calculate the pH of the solution before and after addition of hydrochloric acid. Alright, so let's begin with before. The formula pH using Anderson-Hilbert equation. So we're going to have it to be pKa, right, plus log the conjugate base, which is salt over the acid. Alright, so the pH will be, for this question they give the pK, they normally give the pKa value. For this one, the pK value is, they give it to me 1.74 times 10 to the power minus 5. Alright, so as usual, pK is the negative log of Ka. Alright, so the pKa will be negative log of 1.74 times 10 to the power minus 5. So let me simplify it in my calculator. Okay, so it's going to give us 4.759, which is approximately 4.76 if you are leaving it in 2 decimal places. Alright, so this is points. Now let's impute the pK value here. So it's going to be equals 4.76, okay, plus log the salt, which is the conjugate base. We have the concentration to be 0.1 over that of the acetic acid. We have it to, which is something as ethanoic acid, we have it to be 0.03. So let me simplify this. Everything with my calculator, pH will be, let me punch it. Okay, so we have it to be 5.28 if I leave it in 2 decimal places. So this is the pH of this buffer solution before the addition of hydrochloric acid. Let's wipe this now and find the pH after the addition of hydrochloric acid. Let's wipe below. Okay, so the pH after the addition of hydrochloric acid, 0.005 mole of it will be pH equals pK, alright, plus log. This time around, the conjugate base, which is salt, will minus 0.005 mole of hydrochloric acid over the acid. We then add this 0.005 mole to it. Okay, now note that when a base is added, you come here, add it to the salts after addition and subtract it from the acid, whereas when an acid is added, you add it to the acid in that question and subtract it from the conjugate base in that question. Hope you are following, you understood what I just explained. Alright, so let's simplify. pH equals, so the pK we got it to be 4.76 plus log. Alright, so the concentration of the conjugate base, which is the sodium acetate, is 0.1 minus 0.005. Alright, this is 5 over that of the acetic acid, which is the ethanoic acid, is 0.03 plus 0.005. So let me punch everything together with my calculator here. Okay, so I have the pH value to be 5.19 if you are leaving it in two decimal places. So this is the pH after addition of hydrochloric acid to this buffer solution, 0.005 mole of hydrochloric acid. So guys, this is basically how you can solve problems involving the pH and pOH of a buffer solution using Henderson-Heisenberg equation. And with this, we have come to the end of the class. Hope you learned something interesting. If you are new to the channel, ensure to subscribe for more videos like this. Also like, share, and comment on this video. Tell me how you feel from what you learned from this class. If you seem to have any specific questions to ask, feel free to leave a question in the comment section below, and I will be sure to give you a response. That's it for this class, guys. Thanks for watching.